In this lesson, we're going to learn about independent events. Independent events are events whose outcomes are not affected by each other. So this lesson looks very much like the previous lesson that we did. However, because they're independent events, we're going to treat it a little bit differently. Here's example 1. It says, Mokhtar and Chantel are playing a die and coin game. Each turn consists of rolling a regular die and tossing a coin. Points are awarded for rolling a 6 on the die and or tossing heads of the coin. 1 point for either outcome, 3 points for both outcomes, 0 points for neither outcome. Players alternate turns. The first player who gets 10 points wins. So A says determine the probability that Mokhtar will get 1, 3, or 0 points on his first turn. And then we're going to verify our results. So in order to do this, let's just first find the coin and dice probabilities. So the probability of rolling a 6 would be 1 out of 6. And the probability of not rolling a 6, which would be the complement, we could write it that way, or we could write it this way, the probability of not rolling a 6 with a bar over top. That would be all the leftover numbers. So that would be 5 out of 6. So 1, 2, 3, 4, 5. 5 out of 6. Now if we're looking at the coin, the probability of landing on heads would be 1 over 2. And the probability of not landing on heads, or the complement, would be the same as the probability of landing on tails. And that would be 1 out of 2 as well. So let's look at all the possible outcomes by drawing a tree diagram, and then we'll figure this out. So first we're going to look at rolling a 6 or not rolling a 6. So here we have the probability of rolling a 6, which would be 1 out of 6. We already figured this out. And the probability of not rolling a 6, or rolling any of the other numbers, is 5 out of 6. Now, if you rolled a 6, when you flip your coin, it can land on heads or tails. If you don't roll a 6, you can land on heads or tails. So the probability of landing on heads, the probability of landing on tails, not 1 out of 6, 1 out of 2, tails 1 out of 2, and then the same for if you don't land on a 6. Okay, so what we're looking at here is we want to figure out the probability of getting 1 point, the probability of getting 3 points, and the probability of getting no points. And we have to go back to our other page to see how we receive those points. So to get 1 point, we would figure out the probability of not rolling a 6, landing on heads or 6, and tails. So because we have the OR probability, we need to figure out the probability of each, not 6 in heads or 6 in tails, and then add them together. So first of all, the probability of not landing on 6 and getting heads when you flip the coin would be here. So in terms of the math, that would be 5 over 6 times 1 over 2. Now those are times because both of those are happening, and that would give us 5 out of 12. Now the OR probability was landing on 6 and tails. So that would be over here, landing on 6 and tails. And if we do the math there, that would be 1 over 6 times 1 over 2, which would give us 1 over 12. So to figure out this probability of getting 1 point would be 5 over 12 plus 1 over 12, which would give us a probability of 6/12. And if you wanted to reduce that, 1 over 2. So go ahead and do the same thing for 3 points and 0 points and see if your answers match what I've done. So I just went ahead and filled in all the probabilities for the rest of the tree diagram. And then if we look down here for 3 points, that would be the probability of landing on heads and rolling a 6. So both of those have to happen, and there is no or, so then we would be looking at the tree diagram where we're going here, 6 and heads. So the only solution for that would be this 1 over 12. If we look at 0 points, landing on any number other than 6, and then tails, there would be only one solution for that too, and that would be 5 out of 12. So that's the solution for A. We figured out the probabilities of getting 1 point, 3 points, or 0 points playing this game. Now in part B, it says verify your results for part A and explain what you did. Well, the only way I can see to verify our points is to make sure that the total probability was 1, because that's the highest probability you can have. So if you add the probability up of all the individual events, 1 point, 3 points, or 0 points, we should get a probability of 1. Let's see if we can get that. So the total probability would be equal to our answer for the first part, which was 1 over 2. And then the probability for the next part is 1 over 12. You noticed I added the 1 there. I missed the 1 when I was writing 1 over 12. So plus 1 over 12, and then adding the last one, which is 5 over 12. Now, because these are all out of 12, it's probably not a good plan to use the 1 over 2. It's probably better to use the 6 over 12, or just change that so they all have a common denominator. So I'm going to just change that in here and use the 6 out of 12 instead. Now that they all have the same denominator, I can just change that to 6 plus 1 plus 5 to give us a total probability of 12 out of 12, which is a wonderful thing. Because it's equal to 1, 100%, we've got a total probability of what we wanted to. And because all three make a total of 1, that's verified. Alright, let's take a look at example 2, and that's the last example for this topic. It's a little bit different, let's have a look, than a tree diagram, and we'll see why. So it says, all 1,000 tickets for a charity raffle have been sold and placed in a drum. There will be 2 draws. The first draw will be for the grand prize, and the second draw will be for the consolation prize. After each draw, the winning ticket will be returned to the drum so that it might be drawn again. That's really important. Max has bought 5 tickets. Determine the probability to 0.1%, that's just telling us how to round it, that he'll win at least 1 prize. So a couple pieces of really important information. So the return to the drum part, right? If it wasn't returned to the drum, then it would be a dependent event. But because it's returned to the drum, that everybody has a chance of being drawn again. There'll be 2 draws, so it's not just 1. There'll be 2 draws, grand prize, and the second draw will be for the consolation prize. And then to 0.1%, that's just a reminder piece. And then lastly, the at least once probabilities. And remember we did that earlier. Okay? So I just made a note here. Since the winning ticket will be replaced after the first draw, the probability of winning either prize is the same, the independent event. So just make a note of that, because that's the key piece for how you're going to do your math. So let's first figure out what's the probability of winning the first prize, and then we'll figure out what's the probability of winning the second prize, and then we'll get the at least one's probability once we figured that out. So the probability of winning the first prize, he bought 5 tickets out of a total of 1,000 tickets that were sold. So I'm just looking here, 1,000 tickets, and he bought 5. So that would be 5 out of 1,000. That's the probability of winning the first prize. And because all of those tickets were put back in, assuming he's winning, right? He still has a 5 out of 1,000 chance of winning the second prize. Remembering back to our previous lesson, the probability that an event occurs at least once is 1, subtract the probability that the event does not occur at all. So in this case, that's going to be 1 minus the probability of getting no prizes. So getting no prize is not winning would be the probability of not winning the first and not winning the second prize. So if we look at the math, right, 1 minus, that would be the probability of not first times, remember, and probability is times the probability of not getting the second. Okay, so now that this is laid out, right, we need to figure out how we can put the math in there, right? So the probability of not winning the first prize, the probability of not winning the second prize, how do we do that? Well, the probability of winning the first prize is 5 out of 1,000. So how many do we have left over, right? So if we just want to do that on the side here, the probability of not getting the first prize, that would be 1 minus 5 out of 1,000. And that would give us 995 out of 1,000. That would be the same as the probability of not winning the second prize. 995 out of 1,000. So mathematically up here, 1 minus 995 out of 1,000 times, right? You're multiplying these together. If you want to put this in brackets, just to make sure we're using bad math here, 995 out of 1,000. Now these are going to give you big numbers, but that's okay, you're using your calculator. And we'll get 1 minus 990,025 out of 1 million. Okay, it might be helpful to reduce this if you can, otherwise just subtract and then you can reduce it at the end if you want. Again, there's no reason why you need to reduce. So that would be the same as saying 1 million over 1 million. I have an extra 0 here. Minus, just because you need the common denominator. It's kind of messy just because the numbers are big, but the process is the same. And putting that in your calculator, you end up with 9,975 out of 1 million. If you change that to a decimal place, that would be 0.009975. And if you wanted to look at it as a percentage, that would be 0.9975%. So it's about 1%. So if you're looking at these prizes, and that's when there's only 1,000 tickets sold, okay, buying 5 of them, that's a very, very low chance of winning, less than 1%. Thanks for joining me today.